Thank you very much, Molly. I'm very happy to be here and to be invited for this conference. So the topic of my presentation today will be developing low-cost, safe, and efficient batteries for a new generation of electric vehicle. I will start the presentation by explaining a little bit the challenge that we are facing today. Then I will follow by the market evolution of electric vehicle and plug-in vehicle in Asia, North America, and Europe from now to 2020. And then I will follow by the battery technology for EVs and manufacturing process presently used for mass production. So I will present you some example of size, range, and energy density in electric vehicles such as the Volt or the Nissan Leaf that I had the opportunity to drive last spring in Detroit at the SAE conference. And also, you can have the best electric car, but you still need to charge those batteries. So the battery charging processes should be available, quick, easy, safe, and convenient. And also standardization to fulfill the needs and implementation of those needs. So what are the challenges that we are facing today? As you know, we have some of us signed the protocol of Kyoto and then Rio and Montreal to meet the CO2 emission regulations. The transportation sector is representing 25% of the global energy use and energy-related CO2 emissions, so it's quite significant. We are facing a global increase of vehicles in emerging countries and China and India. And by 2030, 50%, we will assist to an increase of 50% of the CO2 emission worldwide, and by 2050, around 80%. Also, you're all aware about the rising cost of the petroleum fuels. It's going up and down, and mostly up on the long term. Also, urban pollution in major cities. We all have this image of Chinese cities with the smog. Before it was LA, now it's Mexico City, Shanghai, Beijing, but they are reacting, taking act. And also the falling cost of the technology will soon create parity between alternative propulsion and conventional ICE. The cost of the batteries is decreasing and will continue to decrease thanks to mass production and new applications. And finally, national security, the need to reduce oil imports in North America and Europe. Just to give you an idea about energy-related carbon dioxide emission by sector in the US in 2009, around 34% of those gases were due to transportation. The rest was electric power through thermal plants, and 26% residential, commercial, and industry. So the goal is not only to decrease that, but to decrease the size of the pie itself. Market, what is the battery market in the next 5 to 10 years? So the previous study were more optimistic. Those ones from Pike Research shows that there will be an increase of battery electric vehicle sales around the world, mostly in China, as mentioned before, also in the United States and Germany. And globally, in that case, in 2015, we can expect around 1.3 million of vehicles. So it's not as like this one where they were expecting in 2020 around 12 million of electric vehicles. So depending on the source, it can vary. But according to Nikkei Electronic Based, the electric vehicle lithium-ion rechargeable battery market is expected to exceed 2 trillion yen in 2014, around $22.5 billion. And the total market of the battery will surpass the $31 billion. Presently, we are at 8.3 and 16.6 billion. Lithium battery market, it will be involved in mobile and stationary application. We all remember the first lithium-ion rechargeable batteries used in our laptop computers and cellular phones, still available today, by the way, but they are thinner and with more power density, with more energy density. And thanks to larger capacity and higher output, Now they are present in plug-in vehicles. Today you can have cars such as the Chevy Volt or the Nissan Leaf. Soon the plug-in Prius. And due to the lower cost, in the near future you can see new application in vehicular use. You will have electric buses, next generation of trains. In the industrial machinery, forklifts, automatic guided vehicles and power crane, and stationary application to store solar energy from solar panels, wind energy from wind turbines, and also backup system for houses. LG Chem, for example, is already marketing a backup system for houses based on lithium-ion batteries. Battery cost and economy of scale. As we discussed it this morning, the price per kilowatt will decrease. Presently, it's around $1,000, 1,000 US dollars. According to Nikkei Electronics, the Japanese want to make it below 500, so we talk about 200 or 100, $200 per watt in 2015. How are we going to achieve this goal? Fully automatic manufacturing. So the more automatic is the production, the more batteries you will produce on the long term. Also the EV volume production. For example, Nissan Motors is expecting to build around 50,000 electric vehicles annually from 2010. New materials for cathode, because cathode materials represent at least 30 to 40% of the cost, the total cost of the battery. So by using cheaper materials for cathode, lithium iron phosphate or other alloys based. New application, so mass production, industrial machinery, stationary use, also recycling. All this will contribute to decrease the price per kilowatt hour. Just to give you a rough idea, in the past, for example, based to a prismatic cylindrical cells of 8 watt in a mobile phone, you will need only 0.4 batteries to have a power of 3 watt. Notebook, 9 batteries. Hybrid, 125 batteries. But today, for electric vehicle, you need more. You need around 2,500 batteries to provide a power of 20 kilowatt-hour. So you can see that the demand of batteries will increase drastically in the future, thanks to the launch of the market of the electric vehicle. We talk about the players this morning, the big players. So we mentioned China with BYD. BYD is expecting to have a production capacity in 2012 of 4,000 megawatt by making large amounts of batteries, and it's still continuing to invest around $3 billion in plants in China. The other ones, of course, are Panasonic and Sony. In their case, they are continuing to invest a large amount of dollars. And Nissan Motor, they have a collaboration. They are now linked to Renault in France. And in France, they are expecting to build a battery company, manufacturing, for a 2,000 megawatt production capacity. Who are the other players? The Koreans, LG Chem. LG Chem, here are some cells of LG Chem, different sizes for different applications. Electric cars, but also electric pickups and trucks. They are making presently the cells, and then they sell those cells to the OEM, the car manufacturer, who are building the modules and then the final battery. Johnson Control in North America has a partnership with Saft and Varta, if I'm correct, and A123 system, which was supposed actually to provide the battery for the Chevy Volt, but GM chose GM Chem. And GM Chem, as mentioned also this morning, is building a new facility in Holland, Michigan, to supply the Chevy Volt. What do we have in Canada? we have companies such as Bathium. Bathium is located in the suburb of Montreal. They are making lithium-ion batteries. They were purchased by Bolloré. Bolloré is a French group, and Bolloré is making the electric car using the Bathium battery. Bathium is a spin-off of IREC, Hydro-Québec, a company of electricity in Quebec. So if you also, Bolloré is also making separators. So if you are looking for separators for your batteries, you can contact them. Selgar is another one. Electrovaya, it's a company located near Toronto. They started with backup system for the laptop computer, external backup system, but now they expand their facility in Mississauga or Oakville, and they are actually providing some cells for electric Dodge Ram and Chrysler minivan fleet. It's just a small number of vehicles to be used for vans in US Post and Canada Post. The next one is Magna e-Car Canada. Magna International, it's a Canadian company making auto parts for the automotive industry, but they have a partnership since last year, I think, with Ford to build actually the first, or the second, I would say, electric vehicle in North America, but using 100% made in Canada batteries. The last one is E1 Molai. They're located in Vancouver, and presently they are just making small cells for electronics. So in order to be more efficient, to have higher capacities, higher voltage, higher power density, you need to play, I would say, with the chemistry of the battery itself. If the lithium, cobalt, and graphite system has a long time been the standard for the industry, and by modifying the type of anodes using silicon oxide or silicon doped anode materials, you can improve the specific energy by around 30%. And by also modifying the cathode material itself by using other type of materials, you can reach an improvement of 37%. And by also mixing both and balancing the weight of the cathode and anode, 65% improvement. But as Eric was mentioning this morning, the ultimate goal is the lithium air battery, where you are expected to reach around 8,000 watt per kilo of specific energy and high voltages. So during the conference of ABBC in Mainz, Germany, that I attended recently, there were some talks about the lithium air. The lithium air won't be ready and available on the market before 2030, but several groups, research groups in Japan, North America, and Europe are already working hard on this system. And it's expected to provide 10 times, actually, the energy storage of a lithium ion. And used in electric vehicle, we expect to have more than 500 kilometers range compared to 160 presently. And today we are now developing the lithium-ion battery first generation, but later on it will be the second generation improved batteries, and the goal is to reach the lithium air batteries.